Hi, I'm Brandon Graysley. I'm a high school math teacher. I'm going to show you the process of completing the square to change an equation, quadratic equation from standard form into vertex form. So this form of the relation is only really useful for us to see the y-intercept, C, and the stretch of compression factor, A, but the vertex form gives us that same stretch of compression factor and then the vertex HK. So, so what we're going to be trying to do is construct this little squared binomial here. Now remember, when a binomial is squared, we have a nice pattern to it. I'll just give you an example here. Remember this one. X plus 3 squared is going to be x squared plus 3x plus 3x plus, I'm going to write it like this, 3 squared, or 9. Or I'll just rewrite that one more time. That's, we're going to have 2 copies of 3x. And then we have a 3 squared at the end. So it has a special structure. The first value is, the x value is squared, the constant value is squared, and then we have 2 times the constant value times x. So we're going to work backwards to make this happen again. So I'll give you an example here. And so the way this works, we're going to just work on this the first 2 terms. We're going to leave this negative 37 alone until the very end of this, because otherwise we're going to do some work and then undo it again. So it's better to just leave it alone and come back to it. So the first thing we're going to do is factor out the negative 3. That's the a value. We're going to factor it just out of the first 2 terms, though. We'll be left with x squared and plus 8x, and we still have that negative 37 hanging out at the end. So this is not a perfect square yet. It doesn't have this kind of form where we have an x squared, a linear term, and then a perfect square at the end. But we could figure out how to make a perfect square. What I want is x squared plus 2 times something x plus a constant. Well, this is 2 times something x. This is 2 times 4x. Right? So if I wanted, I could put a 16, that is 4 squared, after this to make a perfect square. And I'm just going to rewrite this back as my 8x. If I were to add 16, that would be a perfect square, because this is 2 times 4 and this is 4 times 4. But I can't just add 16 in like that. I'm going to subtract 16 to undo that operation there so that I have an equivalent expression. So I've added 16 because that is half of 8 squared. That's 8 divided by 2 squared is 16. That's why I did that. Okay. So this portion here is a perfect square. I'm just going to use square brackets here for a second. That is the square x plus 4 squared. That's the portion that I have in orange there. This negative 16 here is not part of the square. But you see, we're very close to having vertex form now, except we have this negative 16 hanging out here that I don't want anymore. We're going to use the distributive property. We're going to multiply negative 3 times negative 16 to get that out of there. I suppose we're also multiplying by this first bit here. Negative 3 times this first chunk, this first term, is right there. Negative 3 times negative 16 is positive 48. And then we still have a negative 37 at the end. And look, all we have to do now is clean up the constants. Negative 48 minus 37, or sorry, positive 48 minus 37 is positive 11. And so just to finish this, the vertex here is going to be negative 4 and 11. And that's the process for completing the square. Now this is a kind of a long process to go through. I just want to show you one other little trick. Later, perhaps already, you will learn the quadratic formula, which is useful for finding roots. Well, I'm going to run out of space here. The quadratic formula is useful for finding the roots for a quadratic equation or quadratic relation. And if you haven't seen this already, it might look a little scary. That's what it is there. And anyway, the first part of that, this part here, tells you the axis of symmetry. So the axis of symmetry is x equals negative b over 2a. That tells you the x value of your vertex. So if I look up at this example here, negative b over 2a would be positive 24 divided by negative 6. 24 divided by negative 6 is negative 4. That's our vertex value. And so you can evaluate your relation here, your equation. Evaluate it when x equals, in this case, negative 4, and you'll get the y value of 11. So once you know the quadratic formula, you can use this as a sort of shortcut or a fast way to find the axis of symmetry and use that to find your vertex quickly. Until then, let's use completing the square. Thanks.